Hello students, in today's topic of discussion, we will learn about the UMTS core network architecture, its functionalities, then the functions of SMS, 3G, and then firewall considerations. So these topics are covered under the course Wireless Networks 19 EC 507, 4th unit. Let us quickly go through the course outcome of Unit 4 of Wireless Networks. Once we complete the discussion of Unit 4, we'll be able to write about 3G networks, its protocols and applications. So the course outcome of Unit 4 is defined as to write about 3G networks, its protocols and applications. So let us move on with the topic of discussion, UMTS. What is UMTS? Any idea? The UMTS stands for Universal Mobile Telecommunication System. So this diagram depicts the spectrum of UMTS. So when you observe this diagram, you will be able to see. So the spectrum of UMTS lies in the range of 1885 megahertz and spreads till 2170 megahertz of the GSM band. And this UMTS technology deploys both TDD as well as FDD, time division duplexing as well as frequency division duplexing. So this detailed diagram shows the spectrum of UMTS distribution. Yes. So what is this UMTS, Universal Mobile Telecommunication System? So this is actually an extension of 2G mobile technology. In fact, it is under the 3G mobile phone technology standard, and this is the successor to our GSM technology. So this standard was deployed by 3GPP. So when we talk about UMTS, this has certain features like it deploys packet switching technology, due to which we are able to have a better speed. It employs wideband wireless network, which provides us with good quality. So these are all the advantage of universal mobile telecommunication systems. So let us move on to look at the various network elements from UMTS. So UMTS actually differs from the GSM band of AS2. So here it tries to deploy TDD and FDD instead of TDMA and FDMA. So this UMTS actually deploys a new radio access network, which is known as UTRAN, UTRAN. So this is UMTS terrestrial radio access network. So only with the help of this new RAN or the new UTRAN, the radio access network, the UMTS network architecture is based upon. So we'll have a core network which is coordinating with this UTRAN network. So as we have discussed in the previous slide, so this deploys both TDD, so it can operate in TDD mode, which is optimized for public micro and pico cells, and this has an unlicensed cordless application. Whereas when we operate in FDD mode, this is optimized for wide area coverage, that is the public macro and micro cells. So both these modes are helping us to provide flexible and dynamic data rates even up to 2 Mbps. Yes, so now we are moving on to discuss about the UMTS architecture. So here, our UMTS architecture deploys a new radio access network known as UTRAN, which stands for UMTS and radio access network. So T stands for terrestrial, RAN stands for radio access network. So this is deployed with the help of a radio network subsystem, RNS. So normally whenever we start describing about the architecture of UMTS, this uses the same core network as that of our GPRS network. So similar to that, here we have an interface called IU and one more interface called U suffix U. So this I suffix U interface communicates between the core network, UTRAN, and the user network or the user equipment. So this interface between the UTRAN and the user network is known as U suffix U interface. So when we talk about the IU interface, this communicates effectively between the RNC, which is our radio network subsystem, as well as the core network CN. So this diagram depicts a detailed architecture view. So we'll be able to observe the user equipment or the user terminal UV. So the mobile terminal in UMTS is normally called as UV or the user equipment. So this UE is normally connected to node B. Okay, so we have different nodes. So this is node B. So this is connected to node B over a high-speed network using the interface U suffix U. Okay, the node B are the equivalent of BTS actually. BTS is normally deployed in case of GSM networks. So BTS is known as base transceiver station. I hope you can recollect the concept of BTS, which you might have learned under GSM, right? So several node Bs are controlled by a single RNC network. So you will have a single RNC network, which is a radio network over the IU interface. So these RNCs are connected to the core network through the IU interface. So here the RNCs are connected to the CN core network through the IU interface, and the network actually tries to deploy a packet switched data which is communicated through the IU interface. And through the interface IU to CS interface, circuit switched data is being communicated. And one of the new interface in UTRAN is IUR interface. So you have one more interface called I suffix UR here, right? So the IUR interface here facilitates handling of 100% of RRM. So what is this RRM? Radio Resource Management. So keep in mind this IUR interface facilitates or helps us to handle the radio resource management, and this eliminates the burden of our core network CN. Okay, so UMTS also supports the GSM mode connection, in which case we will have the MS connect to the CN. So mobile switching center, you have a mobile MS connected to the core network through the UM interface to the BSS, and the BSS connects through A. So these terminologies are used in GSM technology. So this depicting the core network in detail. So here you have the interface IU. So where we try to deploy both domains, which is circuit switch domain as well as the packet switched domain. So you try to manage over the resource reservation protocol, the connection setup, as well as we handle the GSM components like MSC, mobile switching center, GMSC, then VLR visitors, location register through the interface IUCS. Similarly, we do handle the packet switched domain, which is handling the GPRS components SGSN, GGSN through the interface IUPS. So in the next session, we'll get into the details of SGSN, GGSN in detail. Thank you.